Okay. Hey, class. Mr. Bean here. I'm with my A3 AP Physics class, and we're going to do the continuation of Lab 11, and we will call this Lab 11B, Free Fall Egg Drop for AP Physics. All right. So what we'll do is we'll briefly go over the theory part of what's happening now. So the theory changes a little bit as compared to last class. So we have theory. Okay. All right, so again, just some general background information here. Um, so we know from previous labs that the magnitude of g, which is the acceleration due to gravity, is a vector quantity. It has the accepted value of 9.80 meters per second squared. Now, when we get into our gravitation unit, which is unit 3, we'll actually do a whole thing on gravity. Okay. All right. So this is the accepted magnitude value. Now, in our experiment here, we will have an object. In this case, it will be the egg or an object here, and it's going to experience free fall. So we'll go over here and write down free fall. Okay. This will be free fall. Okay, free fall. Okay, free fall. All right, so it's free fall, which means that it's going to start with the initial velocity in the y direction is going to be 0, okay, meters per second. And it's going to fall in this direction, okay? Okay, now g is always pointed toward the earth. Okay, so we'll pretend this is here's the ground here, here's the earth here. Okay, this is the earth here, and g is acting downward. So since g is going downward, initial velocity is also going to be downward. We'll do our frame of reference. So here's our frame of reference, FR, frame of reference. Okay, is going to be such that going down will acquire a positive value for today. Okay, and going up will be negative. So for today, going down is positive, going up is negative. This is to help with calculations. Okay, all right. So now, as I drop this here, suppose I took a snapshot as it progressed down here all the way to the ground. Let's say I got a free response question worth 2 points or 1 point that said, draw a screenshot or uh, draw a dot describing the motion of this as it falls to the ground. If I was to do a dot, would it be equally spaced or would they be spread apart for each subsequent moment? What was that, Thomas? Yes. So one might be like here, right? Now, then it should be kind of like wider, right? You're getting bigger, right? So you have to kind of show getting increasing. Because if you showed them that equal spaces, that would not imply acceleration. Okay. So if this was a spatial distance between each subsequent moment in time, this has to be increased because it's showing acceleration. Okay. Damas, is that what you're trying to say? Good. You are correct in your assertion. 2 points out of two on that one. Good. All right. So, okay, so we have G going down. All right. Okay, so this is kind of the background theory here we discussed last class. Okay. All right. Now, which brings us to today. So here is Senator Square, right? And we're right here. And I'll go ahead and use brown here for my shape here. Where's eco drawing here? Here's brown. Okay. Here's this railing here. Okay. All right. Okay. Okay. All right. So we're here. We use black. Okay. All right. So here we have our situation here, and we have a person here, the recorder. Okay. We'll see with a iPad here. Okay. This is going to be video guy. Right. Here's video, and he'll be the timer. Okay. And we have some iPads here, or use your own timing device, but send it to me as an email. Okay. All right. So this time, okay, here's our reference line. Okay. This is our imaginary reference line here, right? Now, I'm going to pretend like this is a Dixie cup. Okay. Here's our Dixie cup here. Okay. And now, we want to put the egg inside the plastic Ziploc bag. So in case it bursts, it'll minimize mess, right? So we have we'll kind of here's like a Ziploc bag here, and we'll kind of Ziploc it like that. And here's our egg. Okay, okay, all right. So here's egg. Okay, okay. So this time here we'll have some string here. So here's some string, maybe 4 pieces of string here, and this is like a parachute. Uh, Parachute device. Okay, so Adamus, what do you think what's the intention of the parachute? Yes, because we wish to have acceleration be close to zero as possible. Okay, we wish it not to gain any speed necessary. Okay, all right. So we have a parachute with the egg. This is a reference. And now this part's okay. We probably need a taller person to do this. Okay, I don't want to minimize anyone's. Okay, I'm not looking at McKenna here, but okay, or Deep T, but maybe Lucas could help out because we need. Okay, reason is that we have to have the parachute extended out too as well, which may be kind of difficult for certain people because of the physical parameters that are involved. Okay, is that a nice way of saying you're short? Okay, okay, all right, okay. Adama or Adam, you can probably help out too as well. All right, we have a person coming in with a message. Okay. When I make this video at home, I usually have a cat that jumps on the screen and on the buttons here and causes havoc. I have a dog that barks because she's hungry and overweight and eats too much. This is for Lucas here. All right, so we have this video timer here. Okay, so, and we have a person here, and we'll go ahead and use a Marvel character here. And we're here, Fantastic Four fans. This is Dr. Reed Richards. His hand, he can stretch, right? So for team, we have Reed Richards here, Fantastic Four. I'll put a 4 here for Fantastic Four. All right, Reed Richards is here. Okay, they might show up in the multiverse. You know, I heard rumors. All right, so we're here. Okay, so we have this parachute here, and here's Dr. Richards here. And now this is Delta Y. So the initial height, Delta Y, is going to be 5.2 meters. Okay, which is right here, 5.2 meters. Okay, let me go right here. Okay, all right, and VOY, the initial velocity in the y direction is going to be zero. Is zero. Okay, zero. Okay, all right. So it's going to fall here, and it's going to hopefully not gain too much speed. You know, maybe a little bit, and it should land here. Okay, and so we wish the egg to survive. Okay, now for timing, so I'll go put down put timing over here. Right, we have time. Okay, or okay, time, which is going to be, we'll call it delta t to describe the duration of time. So from the video analysis, we'll get an initial time, right? We'll get initial time, and we'll also get a final time. Okay. So combined, we should get delta t, which is the time we need to use for our calculations today. Okay. All right. So all right, so now we're here, and so when we look at our egg here, it should be no cracks, right? That's what we want, no cracks. Okay. All right, so we'll make this easy. You have to repeat this until you get no cracks or the egg survives. It may require 1 attempt or 3 attempts or even 4. We have lots of eggs. So, okay, so we want no cracks. Okay. All right, so objectives. Okay, what is it that we are trying to do today? Okay, objectives. Okay, okay, it's objective. Okay, so we'll make it real kind of simple here. Drop egg. Okay, drop egg. We'll say here with parachute. So P-A-R-A. You know how to spell parachute? C-H-U-E-U? U-E. 2 T's? Just 1 T? Okay. Okay. E here? Parachute? Okay, okay, okay. Spell check. Okay, this is parachute. Okay, okay. I misspelled. Okay, this is C student in English. Okay, that's parachute. Okay, there's parachute. All right. Okay, drop egg with parachute. So when it lands, so when it lands, there are no cracks. There are no cracks. Okay. So that's real simple objective. Okay, very, very straightforward. No, okay. All right, cool. Okay, objective. Okay, maybe that's our first objective here. Drop egg with parachute. So when it lands, there are no cracks. Okay. Objective number 2, we also want to calculate acceleration or determine acceleration. Okay, determine, right? Determine acceleration. Okay, and then 3, determine velocity before impact. Determine velocity before impact. Okay, before impact. Okay, almost done. Before impact. Okay, all right. So this lab may extend to Thursday as well. Okay, Okay, question or okay. All right, so objective one, drop egg with parachute. So when it lands, there are no cracks. Number two, determine acceleration. Number three, determine velocity before impact. Okay. All right. So now for those who are doing lab A, we're doing the same thing except we're using the globe. In fact, exactly, except there's no cracks. It's just objectives 2 and 3. Okay, that's what we're doing first. Getting familiar with the iPhone, the iPad, and recording and stuff. So exactly the same. Nothing has changed. All right. So now we'll go down here and we'll talk about calculations. Okay. So calculations. Okay. Okay. Now, consequently, if we calculate this new acceleration and the new velocity, can we compare this with our prior experiment? Yeah, it should be a dramatic reduction. Okay. In fact, here percent error is our friend. Okay, remember when we did the percent error, I think McKenna, your group had 0.83% error. We want like a 99% error if possible, because we want huge friction. Okay, we want the biggest error as possible. Okay, because you want the egg to survive. Okay, all right. So calculations. Okay, one calculation was to, for example, is to determine A. So we'll go determine. Okay, determine acceleration. Okay, so we will make use of the delta y is equal to VOY t, right, plus 1/2 a t squared. All right, so we'll make use of this equation here to determine a. So VOY, so what's given is that we know that VOY is 0, okay? Delta t comes from our video, right? Uh, and we know that delta y is 5.2 meters. Okay, so we know all this already, and this has to come from our video, right? So from here, this is going to be 0, right? So using my advanced algebra skills, right, a should equal delta y 2 times delta y divided by t squared. Okay, so we should be able to get this acceleration here. Okay, that's determining a. And then for our second calculation, okay, there are two methods here. V is equal to VOY plus AT. We can use this equation here, and we also want to use this one too as well. V squared is equal to VOY squared plus 2 times A delta Y. Now, Adamus, should both of these be the same? The answer? Yeah, they should be the same. Yeah, if they're not the same, then we have a problem. Now, don't forget the square, because last class, the honors physics, they went to calculate it. They're saying, "Oh man, Mr. Bean, our final velocity was 10, but this was 100," because he probably forgot the square root. Okay, so unless you want a square root. Okay, all right, so that will be it, and the egg needs to survive. Okay, all right, so materials. So we are limited to the following materials. Okay, okay, we can't use rubber bands. We can't use the marshmallows that are on the desk up there. So materials will be Dixie cup, right? Dixie or plastic cup. Okay. Uh, was it a plastic bag or a Ziploc bag? Ziploc bag to put the egg in. Okay. String. Okay. String and uh, garbage bag. Garbage bag. Okay, so our materials are limited to these only. A Dixie cup. I do have a hole puncher if you want to tie string on it. Ziploc bag, string, garbage bag, and egg. And egg. Okay, and egg. All right, that will be it. And I'll go ahead and post this on YouTube. And away we go. We'll go ahead and hit any questions? Any questions?